Problem 3. Two particles P and Q move in a straight line AB towards each other. P starts from A with a velocity u1 and an acceleration a1. Q starts from B with velocity u2 and an acceleration a2. They pass from each other at midpoint of AB and arrive at other ends AB with equal velocities. Now we have three parts in the problem. The first part is saying find the time at which P and Q cross each other. Second part is saying find the distance AB, and third part involves proving that u1 plus u2 multiplied by a1 minus a2 must come to be 8 times of a1 u2 minus a2 u1. Okay. Now let us represent the problem in the form of a figure. So we have two particles, correct? One is P and one is Q. And P is starting from the point A and Q is starting from the point B. P has the initial velocity u1, acceleration a1 towards Q, and Q has initial velocity u2, acceleration a2 towards P, correct? And they are crossing each other. So C is the midpoint. So they are crossing each other at the midpoint, correct? So at this instant, when the particles are leaving their respective points A and B, I am starting the stopwatch, okay? So say this instant, the value of t is equal to 0, and say when they are crossing each other at the midpoint, then the stopwatch is indicating the time t, okay, when they are crossing each other at the midpoint, then the stopwatch is indicating the time t, and since both have started simultaneously at t0, so the time of travel for P is t and the time of travel for Q will be t as well, correct? Because in this case both the particles have started from their respective points at t0, so there is no difference in the time of travel. Okay. Now if you see, so it is given that C is the midpoint of AB. So what I can do, I can take this distance L and this distance as also L. And I'm taking the right side as positive axis. It's a 1D motion. So we need not to put the vector plus 1D motion, but it is taken as positive axis. Now say, in the first part we have to find the time when the particles are crossing each other. So if you see for the particle P, for P, what is the initial velocity plus u1? What is the acceleration a1? What is the displacement, that is plus L, right side, positive side, and what is the time of travel, that is t? So I can apply S is equal to u del t plus half a del t square. So I will have the equation L is equal to u1 t plus half a1 t square. Okay, let it be equation number 1. So that is the equation S is equal to u delta t plus half a delta t square for the particle P. Okay. If you have a similar equation for particle Q, what we will get? So for Q, what do you think is the initial velocity of Q? That is u2, and u2 is towards the left side. So according to your sign convention, it will be minus u2. A minus 2. What is delta t for this particle? That is again t. And what is the displacement? Now displacement, it is going towards the left side, so it would be what? Minus L. So S is equal to u delta t plus half a delta t square. So we'll get minus L is minus u2 t plus half minus a2 t square. So if I multiply with negative sign, I'll get L is equal to u2 t plus half a2 t square. Let be equation number 2. Got it? Now from these two equations, you can get the time. If I eliminate L, so what I need to do, LHS is L. So in both the equation, LHS is same. So of course the corresponding RHS must be same. So I can write from equation 1 to, I will get u1t plus half a1t square is what? u2t plus half a2t square. And of course the subsequent time will not be 0 because t0 has taken as the initial time. So since t is not equal to 0, we can divide by t. So we'll get u1 plus half A1t is equal to U2 plus half A2t, correct? So you will get the equation half t A1 minus A2 is what? U2 minus U1. So t will come to be what? Twice of U2 minus U1 divided by A1 minus A2. So this is the first part. At what time they will be crossing each other. That is twice of difference of the speed U2 minus U1 divided by A1 minus A2. Okay. That is the answer to part A. Okay. Now in the second part, we have to find the distance AB, and we have taken AC. We have taken AC as L and CB as L, so the distance AB will be 2L. So if you get the value of L, you can find the distance AB. You already got the value of T. Now this is very straightforward. Put the value of T either in equation 1 or in equation 2 and you will get the value of L. So what I am going to do, I am putting the value of T in equation number 1. Okay. So I am putting the value of T in equation number 1 and we will get the value of L. So put T. You can also put that in equation number 2, that depends on your choice. Okay, I am putting it in equation number 1. So what you will get, L is equal to U1 and the value of T came to be how much? Twice of U2 minus U1 divided by A1 minus A2 plus half A1 twice of U2 minus U1 A1 minus A2, that is the value of T, whole square, correct? To be the value of L, so you will see L will be, this will be 2 square 4 divided by 2 will be 2 and this is 2, so 2 I can take common. I can take U2 minus U1 also as a common factor, it is present in both the terms, and then I can take A1 minus A2 as another common factor. Now what is left is U1 plus, now we will get A1 multiplied by U2 minus U1 divided by A1 minus A2, correct? So you will have value L will come to be 2 U2 minus U1 divided by A1 minus A2 and you will get what? U1 A1 minus U1 A2 plus A1 U2 minus A1 U1 divided by A1 minus A2. Now say U1 A1 and you got U1 A1, this will get cancelled away. So you will, the length as what? You will get L is equal to twice of U2 minus U1 A1 U2 minus A2 U1, correct? And here it is coming to be A1 minus A2 whole square. This is coming to be the value of L and L is the half length, correct? We have to find the distance AB. AB is what? 2L, correct? We have to find AB. So AB is equal to what? 2L. So 4 times of U2 U1 multiplied by A1 U2 minus A2 U1 divided by A1 minus A2 whole square. This is the answer to your second part. This came to be the answer to your second part B. Okay, this is the length AB. Okay, now see, in the third part you have to prove that U1 plus U2 multiplied by A1 minus A2 must be equal to 8 times of A1 U2 minus A2 U1. Now in third part is proving, it is given that they arrive at the other ends of AV with equal velocities. See the further information provided in the problem. One information is that they are crossing each other at the midpoint. Then it is given that when they are arriving the end points, that is when P is arriving at B and Q is arriving at A, they have equal velocities. Basically, it must be equal speeds. The problem says equal velocities, but the velocities are in opposite direction, so they can't be equal. So the right language of interpretation must be there, equal speeds. Okay. So same for part C. It means if this is the midpoint and this is A and this is B, correct? So when Q is arriving at this point and P is arriving at this point, so if P has a velocity on right side and Q has a velocity on left side, then both velocities have the same magnitude at the end point. So if it is having a magnitude V, it is also having a magnitude V. Got it? Now see, this length is what? 2L. And P is going with an acceleration of A1 and Q was going with an acceleration of A2, and I am taking this side as positive. So if you are applying V square is equal to U square plus 2AS for P, and I am applying this for P A to B, from A to B, correct? So if you are applying for P from A to B, what is final velocity V? What is initial velocity U1? What is acceleration A1? What is displacement 2L, correct? So what you will get V square is equal to U1 square plus 2A1 into 2L. So I'll get V square is U1 square plus 4A1L. Let it be equation number 1. Got it? Now apply the equation for Q. Okay, and you are applying for Q from B to A. So the initial velocity is minus U2, the acceleration is minus A2, the displacement is how much? Minus 2L, the final velocity is minus V, it is going towards the left side. So I will have the equation what? V square, that means minus V square is U square minus U2 square plus 2 minus A2 minus 2L. So we'll get V square is U2 square plus 2 into 2, that makes 4 A2L. Let it be equation number 2. Okay, so you got basically two equations here for P, for Q. Okay. Now what you can do from the equation, you can eliminate V square. In both the equation, LHS is V square, correct? You can see in both the equation, LHS is V square. Now see, from equation 1 and 2 we can eliminate V. In both the equation the LHS is V square, so we can equate both the RHS. So I'll get from 1 and 2, I will get U1 square plus 4A1L is equal to what? U2 square plus 4A2L. So if I'm taking L, 4L as a common factor, I'll get A1 minus A2 is equal to U2 square minus U1 square. Okay. So we got an expression which is relating A1, A2, U2, U1 and L. Now for the proving, we have to relate A1, A2, U1 and U2. So we have to eliminate L. So in the part B, we already got a value of L. So L was twice of U2 minus U1, A1 U2 minus A2 U1, A1 minus A2 whole square, right? So of L here. So from part B of the problem, put the value of L. So L was what? Twice of U2 minus U1, A1 U2 minus A2 U1 divided by A1 minus A2. That was the value. Let's check. A1 minus A2 whole square. That was value of L we got in part B. Okay. And this you can put in this part of the equation. So you will get, it implies that 4 times of L, that is twice of U2 minus U1, A1 U2 minus A2 U1 divided by A1 minus A2 whole square. This is the value of L, correct? Obtained from part B. And what is with L? A1 minus A2 is equal to U2 square minus u1 square. Okay. Now what is, so this is a1 minus a2 square and this is a1 minus a2. So one index will get cancelled away and you get 8 times of u2 minus u1, a1 u2 minus a2 u1 is equal to u2 square minus u1 square multiplied by a1 a2. So now there are simple maths now, nothing else. a1 u2 minus a2 u1 is equal to what? You can write u2 plus u1 and you can write u2 minus u1 multiplied by a1 minus a2, correct? Now what we can do, we can cancel out u2 minus u1 on both the sides, assuming that u2 is not equal to u1, so it's a non-zero factor. So you will have what? You will have the expression as 8 times of a1 u2 minus a2 u1 is u2 plus u1 multiplied by a1 minus a2. And I guess this is the proof which need to be done in part C, correct? Part C is saying what? Prove that u1 plus u2 into a1 minus a2 is 8 times of a1 u2 minus a2. You got the proof? See, yeah, you got the proof. 8 times of a1 u2 minus 8 a2 u1 is equal to u2 plus u1 into a1 minus a2. So that is the proof for part C. So these are the 3 parts of problem. Problem number 3 for uniformly accelerated motion.